Okay, welcome to our last video for chapter 1, at least the last section that we're really going to cover. Distance and midpoint in the coordinate plane. This is pretty much just an algebra review. Everybody should have had this already, and I think the reason why this is in this section is because, again, we've been dealing with lines and segments, and this is just lines and segments on the coordinate plane. So the distance formula, again, is because on the coordinate plane, you can count units for horizontal and vertical lines, but you can't just count units on a slant, on a diagonal somehow. So you need the distance formula to get the exact length of a segment on the coordinate plane. So again, it's just taking the difference of your two x points and squaring them, and then adding them to the difference in your two y points that you've squared. And again, sometimes formulas are really particular. You have to be very careful how you substitute things in. This one has a little bit more leeway because this order doesn't really matter that much because you're squaring it anyway. So whether you end up with a positive or a negative number here, it's going to be the same once you square it. And adding is commutative. The order doesn't matter. So even if you did the y's first and then the x's, you'd still end up with the same answer at the end. The midpoint formula, again, you're trying to find a point in the middle, so it's sort of like taking the average. That's why they're adding the two x coordinates and then just dividing by 2, and adding the two y coordinates and dividing by 2. Usually you'll see the formula written out this way, and this is actually really good if you have to find the midpoint, because you're going to have your end points that you're going to be substituting in for these numbers. Thinking about it a little separately, though, is better for actually using the midpoint. Sometimes you might be given an endpoint and a midpoint. You have to find another midpoint. This setup usually works a little bit better. And this mx, or also my, means the x-coordinate of the midpoint. Because this is actually the formula, it's just a matter of where you're going to substitute in. And that example will come up on the next page. Okay, so looking here at this coordinate grid, plotting some points, okay, and again, we'll just go through a little bit. But here are a bunch of points on the coordinate grid. I'm going to calculate the midpoint and find the distance of these different segments. So if I'm looking at segment FA, that is actually this one right here. I should have a straight edge, but I think just hand sketching it will serve my purpose. So the coordinate points for F are 6 and 0, and the coordinate points for A are 2 and 2. So that's what I'm going to use. Again, my midpoint formula is I'm adding the two x coordinates and then dividing by 2. So 6 plus 2 is 8, and 8 over 2 is 4. And then I do the same with the y's. So 0 plus 2 is 2, and 2 divided by 2 is 1, which means my midpoint is 4, 1. And if I look at that, 1, 2, 3, 4, 1, that actually makes sense for where my midpoint would be. You could see, those of you who know me, that I had an error again because 6 plus 2 is not 12, it's 8. So when I originally got my point, I went to double check it and it wasn't even on the line. That's my prompt that I need to go back and recheck my math. If I'm finding the midpoint of segment UR, I'm just going to do the same thing. The coordinates for point U are -6 and 2. The coordinate points for R are 4 and -6. And then again, I just plug that in. But since this has some negatives, I just have to be extra careful on my calculations. So I'm adding these still together, -6 plus 4, which is -2, and -2 divided by 2 is -1. And then 2 plus -6 is really 2 minus 6, which is -4, divided by 2 is -2. -1 and -2 would be my midpoint. And if I'm looking at segment UR right here, if my midpoint is -1, -2, I'd be right about there. So I at least know that my answer is reasonable because that point could fall on the line and it looks like it's pretty much right in the middle. Now looking for distance. Well, again, my endpoints are the same. Now I'm just plugging them into the distance formula. Again, it's important to remember that all of that is under the radical. So you don't simplify until the very end. So if I looked at segment FA, again, I'm taking my x coordinates and subtracting, and then my y coordinates and subtracting. So 2 minus 6 is negative 4. I'll end up squaring that. 2 minus 0 is 2. When I square negative 4, I get positive 16. And when I square 2, I get 4. So I get radical 20, which once I simplify that on the calculator, I got about 4.5. Segment UR, again, I'm using the same coordinate points. I just have to be a little bit more careful with this again once I start to have negatives involved. So I'm taking the difference of my x coordinates. Actually, I think I did the y's first on this one. So, but it just goes to show you it doesn't really make a difference, okay? Because if I have negative 6, negative minus 2, I actually did my y coordinates here, and then 4 minus negative 6 is 4 plus 6. I square all that. Negative 6 minus 2 is negative 8. 4 plus 6 is 10. Negative 8 squared is 64. 10 squared is 100. So I would have radical 164, or if I put that in my calculator, I would get about 12.8. So again, technically, if I'm really going by the formula, I did my y's and x's backwards, but it doesn't matter because addition is commutative. I could do those in any order. Just a little point, if I wanted to look at this, UR is right here. Technically, I could draw in a right triangle. And again, it's all about if your answer is reasonable, not necessarily knowing if it's absolutely exactly right. It's more if it's reasonable. So if I look at this right triangle, UR is the hypotenuse. Well, this leg would be 1, 2, 3, 4, 5, 6, 7, 8. This leg would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, 8 squared plus 10 squared equals this squared. That's the Pythagorean theorem. And again, if my longer leg is 10, my hypotenuse has to be the longest side. So this 12.8 is at least a reasonable answer. And also my 8 and 10 matched what I just counted out. So that's the basics of midpoint and distance. This is a little bit more challenging, and it goes with kind of splitting up the formula a little bit like I had showed you on the previous page. So I have to calculate an endpoint of the segment AZ, okay? A is 2, 2. Z, I don't know. That's why I just have it as XY. But I know the midpoint is 5, negative 3. What are the coordinates of Z? So this is what I'm trying to figure out. So again, I know that the x coordinate of the midpoint equals the 2x coordinates divided by 2. I knew this endpoint. I did not know this one. The formula is the same. Where I substituted in changed. So the first thing I want to do is I want to get rid of this 2 down here, and I do that by multiplying by 2. Well, if I multiplied by 2 here, I have to multiply by 2 there. Those cancel out. So I get 2 times 5, which is 10, equals 2 plus x. And when I solve, I get 8. Then I'm going to do the same thing for the y's. So again, I kind of started without those there. Okay. The y coordinate of the midpoint is negative 3. And it is the 2 endpoints added together divided by 2. Well, I knew this y was 2. I did not know this. That's why I have 2 plus y over 2. Same thing, I want to get rid of this 2 down here by multiplying by 2. Whatever I do on one side, I do to the other. I get negative 6 equals 2 plus y. and when I solve, I get -8. So the coordinates of z would be 8, -8. So when I look at this, okay, if I'm looking at A, the midpoint, okay, AZ, the midpoint, so let's see, if I drew in AZ based on what I found Z to be, which is 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, that's 8, -8. Here's my segment AZ. It told me that the midpoint was 5, -3. 1, 2, 3, 4, 5, 1, 2, 3. And that actually did work out right there. So again, this right here goes back to using the formula this way. This is the coordinate of the midpoint. This is the endpoint you do know. You leave the endpoint you're looking for as just a variable. So again, hopefully that's enough to get you through section 1-7, and come to us with any questions you might have.